So in a couple weeks, I'm going to be, let's see, it's the week of, and I'm hoping to stay in the meetings. I'll be in California, so I don't know. Let's see, what week is it? It's, yeah, it'll be the 21st.
Mm-hmm.
And then July 5th, I'm going to be there too. So I'm hoping to still do the meetings, but I don't know. In case I don't know if somebody, do you guys know how to do this? How to record them?
Not really. I could
I
figure
can
it out, but
I can, yeah.
If you do it, you have to just make sure you do a hangout on air and not just a hangout.
yeah, that's the main part.
Yeah, then I know it's once you do it a few times, it's basic, and you have to make sure you start the broadcast and that records it. But
Okay.
I don't know. Maybe someone else can try and do it Thursday and just practice. I don't even know if we have to do Thursdays. But anyways, just so you guys know, I'm hoping to still make it because I want to.
So you said starting this Thursday or when?
No, no, sorry, 21st of June.
Okay.
So I'll tell you guys later. Okay.
Okay.
All right, should we start?
Yeah, let's open this thing. Well, at least I'm kind of happy that we can this next quiz, I mean exam will remain open until Monday instead of just a couple of weird days like last time.
Right.
I was kind of mad. I was there, really?
Yeah, well, it's the end of the week too, so it gives you more time.
Mm-hmm. Yeah, I was. I just came from the institute and I was talking to one of my friends. She was like, "So what do you have planned this weekend? You have any dates and stuff like that?" And I'm like, "Nope, I got nothing going on." Okay, so have you opened the quiz, Jordan?
Yeah.
Yep, I'm just downloading the Excel sheets that we'll need.
Oh, okay, the soccer shoes and the
hot dog
thing.
nutrition.
Hot dogs, hot dog nutrition, nice. Wow. Okay, the first question says, in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different than the others. I mean, from the others.
I would say true, but I don't know. Actually, I think it would be when there is insufficient evidence that they're all the same.
Yeah, I think it's false. Because usually when you reject or when you fail to reject, it's insufficient.
Okay.
So when you reject,
I found something that says, if the means differ from each other in comparison to the variability in each group, then we conclude that the means are not all equal. If the means do not differ by much when compared to the spread of the data in each group, then we do not reject the hypothesis that all the means are equal. So that is false then.
Yeah, because the alternative in this type of test is always at least one is different from the others.
Yeah.
I thought the hypothesis were like they were all equal.
The null is.
Oh, the null is okay.
But this is, yeah.
Okay, gotcha. Yeah, because I'm reading this after. Why not? Okay, moving on. What requirements?
False?
Yeah, it is false.
Okay, just wanted to make sure.
Okay, what requirements need to be checked when performing an ANOVA hypothesis test? I think the data in each group are normally distributed.
Yeah, and then the variances are equal in each group.
Sample means are all positive?
Well, they are going to be all positive, like they say in the. Wait, hold on. Let's see. They
Yeah,
say
F
no. Wait, something
distribution
else.
is F distribution is never negative,
Okay,
but
maybe
Oh,
that's what I'm thinking.
that
okay.
doesn't
Maybe the
mean that
sample mean could
the
be.
sample means are,
Yeah, yeah,
because
you're
you could
right.
have one negative one and it could make it all positive,
Okay.
or it could make it positive.
Okay.
Yeah.
But hey, we have more than one chance, so
No, no, those are the only two because I just found them here on the
Yeah.
readings. Hmm.
yeah.
All right, all right, all right. Okay, let me see.
So 5, I think, would be a QQ plot for each
Yep.
group.
Hmm.
That's what I think too.
Okay. Oh, I have a question.
Yeah.
So when I try to do a QQ plot, how do you make the line straight? Because I know there is a way to do it.
Do you sort them from smallest to largest? The
How do you do that on Excel? Because I saw the one day the guy did it, but I don't remember how.
So if you highlight the column of data and then you go up to like your home bar, or you should
Hmm.
see a sort. Like I think it's next to A to Z, or sort and filter. Do you see that? It's like the top right area.
Yeah, I'm looking for it.
Should be on your home tab. If you click on that, then you can. Oh wait, is that? Wait, maybe I'm thinking of. Um, yeah, it should. And then when you click on the sort and filter, then there's the smallest to largest option that you.
Sort and filter.
Yeah, do you see that on your Excel?
Uh,
Top right.
because I have a Mac.
Uh, uh, I could ask my husband. Hold on. He does. Hold on a
Oh,
sec. Do you not see? Do you see it? I'm assuming it would have that option.
It should, but I think Mac is evil, so I wouldn't know.
okay, got it. Yeah, okay, I found it.
You found it?
Yes, thank you very much. Yeah. Okay, perfect. Yeah. All right.
So yeah, once
Gracias.
you do that, then it fixes the points.
Then it shows. Okay, perfect. All right, thank you. You are the woman. Okay. So 5 is construct a QQ plot for each group.
Yeah.
Yep.
Okay. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variances. I think that's the answer, right?
Yeah.
Well, I think it might be. Hold on. Do you see that in the reading? Because it might be the third one too. Because of some of the videos I saw.
Well, in the reading, it said that if the largest variance is less than or equal to 4 times the smallest variance, then
Okay.
we will conclude that the variances are equal.
Here I found it. If the largest variances is at least 4 times as big as the smallest variance, we will conclude that the population variances are not equal.
Well, that's saying at least as big, right?
Yeah.
Mhm.
This is saying is less than. So shouldn't.
If
Yeah.
the largest
So they,
variance is not 4 times as big as the smallest variance, we will conclude that the population variances are close enough. That's on the 3.3 how to conduct an ANOVA test. It's at the very bottom of the blue thing.
I'm just worried that they were tricking us with the other option. Because I know I read the 4 times thing too. The bottom of the 3 thing.
yeah,
Is it?
I
Or
found it under 3.2. Yeah, and it's just right there.
So is the third one?
is at least 4 times? It says it is at least 4 times as big.
It says if the largest variance is less than or equal to 4 times the smallest.
Yeah, so the largest variance is less than 4 times the smallest variance.
So it's the second one then.
Yeah.
Okay.
Because
Let me try and find these notes. If we have another chance, obviously. So I wanted to see where I in the thing they took the largest variance and made it less than, or thought if that's less than 2 times the smallest. And if it wasn't, then it didn't pass. Let's see. So the variances are not equal. Okay. If it was, then it is. Yeah, I don't know. If we miss it this time, I think it's the third one. But we can try that one.
Okay.
Okay. Just because I did that same thing a few times in some of the videos.
Okay.
But I'm confused now. All right.
An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, then there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
There is 7.
7?
Yeah.
This is like 4 times 2 minus 1.
Did you do, let's see, 1 dash, so in addition to those 3, did you do 1 dash 4, 2 dash 4, 3 dash 4? What am I missing here?
Well, I just wrote it down myself. I did 1-2, 1-3, 1-4, and then 2-3, 2-4, and then 3-3 and 3-4. Which
Do you do 3 dash 3?
It shouldn't be there. I don't know why I did that. I was just going along.
Okay, so 6 pairs. 6 pairs?
Yeah, 6.
Okay.
Yeah.
So it's 6 instead of 7?
Yeah.
Yeah.
Okay. Okay. Yeah, because it will be 4, 1, 4, 2, and 4, 3. Yeah. Perfect. All right. Now we need to use the soccer shoes. Okay.
Oh, the soccer. Okay.
Clear everything because I don't have it clear.
So there's 5 different things here? Okay.
Dang it.
Okay. Sorry, I'm gonna have to start all over again.
Keep doing the same thing over and over again. Come on.
Okay.
There we go. Copy.
I think I got mine. Let me know when you guys are ready.
Sure. Give me 1 second, I'm almost done. I had to start all over again.
No, there's so much stuff.
Okay.
Okay. Do we also have to type the socks?
I
Yeah.
think so.
Yeah, because we did, yeah, you know.
Okay. Okay, let's see. So what's question number 1?
For number
The-
8,
Yeah, the smallest variance.
I got 27.208.
Yeah, that's the one I'm looking at.
Hold on, I got 2 more variables to paste.
Sure, no
Okay.
problem.
Okay.
Okay.
So it wants the smallest variance,
Mm-hmm.
27.208.
Yeah, that's the one that we got to. At least I got. That's the one that you have to write, Becca?
27.208.
Yes.
Yeah.
Yeah.
And then the maximum is 53.1558.
Yeah.
Okay.
Sorry, did you say 53.158?
Yeah.
Yes.
Okay, yeah.
So the test for equal variances is satisfied for this data.
So I got true for this. But maybe you guys, what do you guys think? Because I did the same. See, I did that thing I was talking about earlier in the videos. They
Mm-hmm.
took the largest and saw if the smallest times 2 is equal or was greater than the largest. And if it was, then it passed the assumption test or the thing and it's equal. And if it didn't, then it's not equal. But I don't know.
Are you sure they were finding the equal variances?
I'm pretty sure.
Hmm.
Well, let's try doing the 4 times thing and see what.
4 times 27 something? So that's gonna be like
So
7.
108.
if the largest is at least 53.158 times 4, right?
Yes.
If that's
108.832.
wait, what?
27.208 times 4. It's
Oh,
108.
I'm thinking. Sorry, I did the big one. Yeah, 20 times 4. 108 point. So we have to figure out if that's.
It's the largest variance is less than 4 times the amount. So I would say that it's true.
Yeah, it says if the largest variance is less than or equal to 4 times the smallest variances, then we will conclude that the variances are equal.
Yeah, I said true too. I just did it a different way. So hold on, I'm trying to think. So this is 4 times as big as. So we took. Oh, so we're trying to say that times 4. If that's. This is where I'm confused.
So the minimum of the smallest variance you multiply it times 4.
Yeah.
And if the maximum variance is equal or less than 4 times that number, then it is true.
So that's great, but that's greater than the largest.
Yeah,
Right?
so the largest variable is less than 4 times the smaller.
Yeah.
So it'd make it equal.
So it's equal. Okay. I'm just thinking too much, I think.
I know. I just think it's weird how you said a video said a different thing than the textbook.
I know. And I did it a few times. So if you watch those videos later, then you'll see what I'm talking about. I think it's on the homework. I just looked back. It's on the homework one, and then
Yeah, I was looking
the
at
prep
something like that.
assignment. Sorry, what?
I was looking at something like that too.
I think it's
Yeah.
the.
Well, on the prep assignment, because that variance thing, the rule of it, it's the answer for the prep assignment number 2.
Oh, that's what it is.
The answer. And so that's what I was looking at, and it says the rule is if the largest variance is not 4 times the smallest variance, then we will conclude that the variances are equal.
Okay.
So that's just weird. I don't know. Does it have to be exactly?
No, it has to be.
No, I don't think it just has to be greater or less than.
Yeah.
So do you think, so the answer that you're looking at, oh, never mind. Okay. Okay, so we're gonna do true, right? For 10?
Yeah.
Yeah, no, I'm doing the
I
plot
think,
thing.
sorry,
I'm doing number
11?
11. Yeah, so I started with 1. The first one it is
Oh, I hate these plots. To do these for 6 of them. Gosh, they're so dumb. I wish we could do it like they do in the videos, where they do them like all at the same time. But we have to do 6 different ones. We can't do stuff like that, can we? At least I don't
no.
know.
So the first and the last one it is normally distributed, if you want to call it.
You're doing, which ones did you do?
I did the first and the last.
Okay. What do you want? I'll do a second and third. You gonna do those? Or are you?
Which one do you want me to do?
The fourth and the fifth.
Fourth and fifth?
Yes.
Okay.
So I think the second one is normal too.
Mm-hmm.
Ugh, dog. Not dog, cat. Yeah, the fourth is normal.
So is the third.
How about the fifth?
The fourth is normal.
Mm-hmm.
I will copy and paste the fifth one now. It's normal.
Yeah. Okay, so.
So they're all normal?
Mm-hmm. True. Okay. Go to 12.
We don't use SPSS, do we?
No, but I think we can still get the p-value in this,
Yeah.
right?
Yeah, the p-value should be in the
The little corner.
thing right
Yeah, we
there.
should have it.
Point
Oh, it's telling us.
0809.
But it says,
What's the SOX data? Oh, the data we just. So we just have to take it out and then.
Oh, of just the socks?
okay,
Oh
so,
yeah, I think it's the last column. Just take that one out and then.
yeah,
Oh, I see.
so the
I
last
see.
one is the one that needs to be taken out?
Yeah, whichever one you put the socks in, which I think
Okay.
we did 6.
So it's 0.309?
Yeah, 309 point. Yeah.
Yeah.
I think it's to the right, right?
Yeah, that's what I kept saying.
Mm-hmm.
Yeah.
It's always in the right tail or something.
Mm-hmm.
Yep. and
Because
it
it's always like right, left skew. I mean right skewed.
Yeah.
Yeah, it's right skewed.
Okay, now the DASL hot dog nutrition.
Woohoo.
Talking about hot dogs, have you girls ever had bacon wrapped hot dogs?
Of course.
Oh, you have? Of course.
I'm American. I would hope so.
Uh, yeah, those are good. I mean,
Mhm.
they're not good for you, but they definitely tasty.
No, one time at my husband's old apartment with his old roommates, we
Mm-hmm.
made meat meat sushi. So we did like a bunch of like ground beef and seasoned it and everything, put cheese inside it, wrapped that in bacon like sushi,
Uh-huh.
and then cooked that on like a skillet kind of thing. It
Oh,
was pretty good.
yeah.
Yeah.
I thought you were gonna say that you did like a steak tartare.
No, but that'd be good. I should try
Yeah.
that.
Mm-hmm. So okay, let me see.
So first we're doing the calories.
Yeah, the
Oh,
colors, right? Okay.
Okay.
And then we do so I'll do the beef, and you girls could pick the other ones.
are you doing the QQ
Yeah.
thing?
So
Okay.
I'll do the beef, and maybe Jordan, you do the meat, and Becca, you do the poultry.
Do we
How
have
about
to put this in the? Are we just doing the QQ plots?
Yes.
Oh, we're doing the
I was
okay.
gonna put it in my other one first. Hold on.
Okay, the meat looks normal.
All right. Did you want me to do the poultry or the?
Yeah, the poultry.
Okay.
I mean, I did the beef, and the beef looks normal. I'm sorry.
Okay, for the calories?
Yeah, for the calories.
Okay. And which one am I doing? The I don't know. The beef or the meat?
You're doing the meat.
Okay.
And I think we have to put the values also on the chart.
That's great.
Yeah.
Oh, this one.
Mine looks normal too for the poultry.
Okay.
Mine looks normal too.
Perfect.
So.
Okay. So, oh, cat. Darn it. Okay, so 14, we can assume that all the variances are equal.
Well, it could be one or the first or the second. Can we assume that the?
It's probably going to be the assumptions have been met. It's safe to assume all groups are normally distributed from the Q and Q plots. And we can also assume that the variances are equal.
Is that guaranteed that it's equal if they're normally distributed, or do we need to check the test, do the test thing?
It just says that the ANOVA requirements both have to be met. One of them is that it's equally distributed, and then the second one is the variances are equal for each group. So
we should check that maybe, right?
Yeah.
Let's see what.
I mean, so just multiply 5 over 8.566 times 4. Is that how you do it? That's how you do it, right?
What? Sorry,
To
I have
see-
a cat sitting on my back.
Oh. No, to see to check if the variances are equal.
You take the. Which one do you multiply by 4? The 4 times
smallest variance.
smallest. Yeah.
Mhm.
I'm gonna do the other one and see what it comes up with too.
Okay.
See if we get the same answer here.
Mm-hmm.
So I have that it's less. The largest is less than.
Dang it. No.
No, so it is true then, because
It does, yeah.
mhm.
Is that what you guys got when you did the other thing?
Yeah. Yeah, I mean the largest is like 600 something, so 5 over 8 times.
The heck am I doing?
What was
What?
that?
My computer's doing something weird and I don't know what to do.
What do you have?
What?
What do you have? A PC or a Mac?
PC. Mac is evil.
Oh my gosh. So do I agree on the first one then?
Yeah, the first one? Right?
Yeah, for 14?
Yeah.
Okay.
Okay.
Oh, let's see here. We're almost done, I think.
Yeah, we have 18 problems. So
Okay. So it says, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. you should find that the degrees of freedom are 2 and 51. Oh, yeah, that is true. And the P is 0, 0, 0, 0. So if the P is low, we
Did they
reject
give
the
us the level of significance that we're supposed to? Was it 0.05?
Well, I don't think it really matters what the level of significance would be because the P is 0.
Yeah.
So that would mean that we reject the null, which would mean that we have.
Okay. We have sufficient if we reject.
Yeah.
But I think that it's different. I think it's still. Oh wait. Wait a second, because it's either this third or fourth.
I think it's at least one, because we don't know if all of them do, but at least one of them. Because that's technically what the alternative is.
Yeah, I think that's right.
So which one is it?
The last one.
This one?
Hopefully. I think that's right.
You have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories. Okay.
Yeah.
16. Oh gosh, now the sodium levels. Are you kidding me?
Oh man.
Okay, so you want to do the same? I'll do the meat and the beef, and you'll do the meat and poultry.
I was gonna.
No.
Yeah.
Okay.
Yeah. Well, no, kitty, don't do it.
So you have a cat and a dog, Jordan?
Yep.
Nice.
They don't fight?
No, they try to play with each other, but we're too scared that the dog's gonna accidentally rip the cat's head off. So.
Oh, that's so funny.
Okay, for the meat, I want to say the mine are normally distributed.
Which one did you do?
The first one.
Okay.
The beef. I'm sorry, the beef. I keep missing. Sorry.
I was about to do the meat, and I was like, wait.
No, you're doing the meat. Sorry, I'm sorry.
That's okay.
Did you say it's not normal?
It looks normal. It has like a little bump, and then it goes like close to the line. So.
Yeah, mine's normal.
Fall off the chair.
Mine is approximately normal. As if I know what I'm talking about. I think it kind of goes up and then it's around the line.
Normal just means it's really close to the straight line.
Mm-hmm.
It doesn't have to be right on it, but most of the data is right around it.
Yeah, it's around it. It's just
me too. Mine too.
A little and then comes back down.
Okay.
I hope.
Now we need to do the.
Yep, I'm doing that. So 4 times the smallest one is 28,723. And the largest variance they give us is 10,492.
Okay.
Oh wait, did you already do the math? Did you say? Oh.
Yep.
I'm just putting.
So it should be. We can assume that all the variances are equal.
Okay, give me 1 second.
Wait.
Yeah.
In question 17, it says, despite the possible problem with the Q and Q plot for poultry, you decide to use ANOVA to discover if the mean sodium levels are the same for all 3 groups.
So it might be the second one? Or no. It might be.
I was like, I kind of want to look at it now. Just to, have a second look at it.
We can share our screens. Do you want to do
Okay,
that?
so who's got the poultry?
Let me find mine. I have so many windows here. Just a sec. Yeah, maybe. I wonder if mine's not. I don't know. Okay, share. I think it's this one. Do you guys see that?
Okay, let me see. It looks normal.
Can you? Oh wait. Can you see it? What I'm? Oh, you see what I'm doing. Never mind. Do you see the
There,
graph
There
now?
you go. Sort of.
Let me scoot up. Is that better?
a little bit more.
Is that on?
Mm,
Okay, I see what you're talking about.
Yeah. See, I don't know because I've answered this question wrong before.
Yeah, well,
Almost.
it looks like it should be identified as normal, but yet it's kind of one of those in-between ones where it's
Yeah.
not obvious, but it's
Mhm.
not like, oh man, that's like, you know.
Right.
So I can understand the little problem. I mean, I don't know. I really don't. Most of them
I
are
think the
not
third
normal.
one. It could be like it's not. They're not all normally distributed, but the variances are equal.
It could, but yeah, that's probably it.
Okay, so it makes me wonder then if mine is equally distributed, but it doesn't say that on the problem.
If yours is, can you share your screen, or is it only me who
Let
did
me
the
see if I
call?
let me see if I can.
It should. You go up. You know how to do that? Like,
Yeah,
okay.
if I can find this. Let me see. I should test. So let me see if I can open it. Can you see it?
Yeah.
So what do you think? Is it like
Yeah. See, that could be a debatable too. I think it's
Yeah.
close, but it's so.
Mine was pretty close to it, so.
I'd say we try the third. I think that's probably right because we know for sure that they're equal, but not the other.
okay? Should I stop sharing the screen?
Sure.
How do I do that?
I think if you go up top, it should give you an option to stop screen share. Is there like a green thing up top? Oh, did you do it?
Yeah, I think it stopped.
Yeah, I think you did it.
Okay. All right. So what should we get?
So, what is it asking for? Despite that, you decide to use it. What's the p-value?
Mm-hmm.
Is it 0.179?
Yeah, 0.179. Yeah.
Okay, what conclusion do we draw? Level
We
of
need
significance is 0.05.
that we do not have sufficient evidence to reject the claim.
Yeah.
The second one, right?
Yes.
Because it's greater, so insufficient. Oh, wait.
So we do not have sufficient evidence to reject the claim that all three hot dog types have the same mean.
Well, it might be that at least. The last one says at least in it. Oh, wait. No, but it says, yeah, it says sufficient. So is it only one? We do not have.
Yeah.
Okay.
Usually there's one of each, or there's two of each, but this one there's only one, and then three of the other.
Okay. Who wants to be the guinea pig?
Do we have any we were worried about? I think we got them all, right?
Yeah, I think we did.
So I think 6, the one I was worried about, I think because how it says the third option, the largest sample mean, I think because it says sample mean instead of variance, so we should have done the right one with the 4 times.
Yeah.
So
I don't think it has anything to do with the sample mean.
The only one I was What did you guys answer for 16?
The third one.
Or actually, I don't think it was 16. It was 14.
The assumptions have been met. It's safe to assume that each group comes from a normally distributed population, and we can also assume that the variances are equal.
I don't think that one is the right answer. Because on this one, it only tells us to do the Q and Q plots. So we're only basing it off of the Q and Q plots.
No, but we did the work. I mean, I have mouth work written down here.
Yeah,
know.
I typed
Good
the
thing.
values on the chart too, and
Because the largest is less than 2 times, or yeah, and then you guys had this. I thought you guys got the same thing.
That's what I got that, and I know that it's all right. I know that all the variances are equal and stuff, but this is the first question that has to do with that problem. So we wouldn't have looked at anything else. We would have only looked at the Q and Q plots for this one. And I think it would be that we can't assume that the variances are equal because all we know is that it's normally distributed.
Well, but we just put all that information into
yeah.
that chart, and so then from there you can see.
Mm-hmm.
Yeah. I don't know. We'll see.
Okay, so for number what do you have for 16 again? For 16, yeah, 16.
16?
Mm-hmm.
The third one?
Yeah, 16 was the third one.
The assumptions have not been met.
Yeah.
It is not safe to assume each group comes from a normally distributed population.
Yeah, but the
But we can.
variances are equal.
Okay. Okay, let's see. All right. Should we submit?
Yeah. All right. Who wants to submit?
Okay. I
I
guess.
felt good about it. I think we probably did okay.
Okay.
But we've said that before.
Okay. Okay. So who wants to do it? Who wants to take one for the team?
All right, I'll do it.
Okay.
Submit here.
What do we get?
Let's see. We missed one.
Which one?
Number 3.
Number 3?
What did you guys put for 3? Did you put true or false?
I put false.
That's what I put.
I have false too.
That's the only one we missed. That's
So
easy.
Well, then it's true.
It is true. Okay.
That was the only one we missed?
Yep.
Okay.
I'm going through here again. Yeah, we only missed one, but we got them all. Nice.
Okay, perfect. Yep. Okay, perfect. Sweet.
Ouch.
So, Jordan, are you gonna be able to meet with us on Thursday?
I should be. That's 6.
Yeah, 8 p.m. my time.
Yeah. I usually only work mornings, so I'm done at like 4 at the latest.
Okay. Where do you work?
Applebee's?
Are you a server?
No, I'm a host and I'm car side to go.
Well, you're a hostess with a mostess?
Oh yeah.
Because I work as a server, so that's how we call
Okay.
them. The hostess with the mostess. All right, girls. So I'll see you Thursday. Okay?
Okay.
All right.
All right. See ya. Have a good week and then rest of the week. Bye.
Yeah.
Okay, see ya.
Yeah. Bye.